Hey y'all, in this lesson, we're going to expand on the last video where we dissected polynomials. We're going to take that dissected polynomial, and now we're going to graph it and talk about the end behavior of the graph. I've got 4 different scenarios here that we are going to explore, just different possibilities that you will probably run across in polynomials. And as with the other lesson, all of these polynomials are already factored. So some of the hard work is already done for us, but this is just going to kind of help us skip to the most important parts. So we're still finding our end goal is to sketch the graph, but to do that, we still have to dissect it. And that means finding the x-intercepts, the multiplicity, the degree, the leading coefficient, the y-intercept, all that stuff. Because remember from the last video or the last lesson, I had started to kind of show you a little preview of maybe what the graph would look like, because all of that plays into this. So just by looking at a polynomial, you can kind of see how you can envision how it's going to look once you graph it. So these are just sketches because we're doing it by hand, but we can still get a pretty good picture of what's going on here. Since I did go into detail of dissecting these polynomials in the last video, I'm probably going to go through that a little bit faster on this video. So if you need to go back and watch that again to kind of refresh, feel free to do that. So we have a polynomial here, f of x equals x plus 2 times x minus 3. And if I'm just looking at this for the x-intercepts, that was where we took both factors and set them equal to 0 and solved. And we would get -2 and 3 if we were to solve those. So this one has 2 x-intercepts. And then the multiplicity at those x-intercepts, that comes from the exponent on each factor. So we have a multiplicity of 1 at -2 and a multiplicity of 1 again at -3. So remember from the last video that those would mimic a linear function at those x-intercepts. And then that tells me the degree. This is a second degree polynomial. So even degree, because 2 is even. And then the leading coefficient comes from multiplying those terms with x here. This is x to the first, because the exponents on the factors are to the first. So we have, if I were to expand that out, I would end up having x times x, which is 1x squared. So we have a leading coefficient of 1. So we have a positive even degree polynomial. And then the last part, I believe, yes, E was the y-intercept. The y-intercept is when x is 0, plus 2, 0, minus 3, and we get +2 times -3, which is -6. So that is 0, -6. So I have very important information here. I've got x-intercepts, I've got multiplicity, I've got even degree, positive coefficient, and a y-intercept. And so I'm going to, an even degree, I don't think I have the, diagrams here, but an even degree polynomial. So let's look at a couple even degree polynomials really quick, just so that you can see what I'm talking about. Clear that. Even degree means that the highest exponent, the largest exponent, is an even number. So if I do x squared and hit graph, you can see that's a U-shaped graph. And then if I do x to the 4th, hit graph, it looks a little funny down here. That's okay. You get the point. We're looking at the end behavior. It's also, both points are up. And then if I do x to the 6th, you probably guess what's going on here. and hit graph, again, both points are up. So even degree, positive coefficient, points up. If I change that to a negative in front, graph it, now I have a different story. I still have both endpoints pointing in the same direction, but now they're pointing down towards the negative. So I have two scenarios here. I have a positive coefficient, even degree, both arrows go up, and then I have a negative coefficient, even degree, both arrows point down. So for this case, I have a positive coefficient, even degree. This tells me that my endpoints are going to go the same direction, pointing up. And now I can draw my graph. I have enough information that I can sketch a graph. I can get a pretty good idea as to what's going on. I have x-intercepts at -2 and +3. -2, +3. They were both x to the first. So before I can figure out if the line's going this way or this way, I'm going to focus on that the both endpoints were up. So if I am hoping to start here and end here, then the only logical way I can go is through there and then back up there. But I don't know, I need to know how far it goes down. So the y-intercept is 0, -6. And you don't have to do it in this order. It's just kind of how I would do it. And what else do we know? Multiplicity. These are multiplicity of 1. So that's going to be a linear type function. So that's a rough sketch. Now, if I just join all the pieces together, I know that my arrows are pointing up in the same direction. I know it mimics a linear function through the first x-intercept. It goes down to -6, and then it goes back up because I have to end in an upward position. I got kind of off there, but close enough. So I just had the separate little pieces, and then all I did was kind of fill in the middles, and that's what this graph would look like. That's it. That's all you have to do. It's a very rough sketch, as you can tell, but it is telling you a lot about the function. So now if I describe the end behavior, if it tells you describe the end behavior, then what that means is they're going to ask you, if it's a homework, they're going to say, as x approaches positive infinity, so this is the positive direction, the y values are also going in a positive infinity direction. So f of x, y, also approaches positive infinity. Then on the other side, as x approaches negative infinity, that's an arrow, that means approaches. Again, the y values are pointing in the positive direction, so f of x approaches positive infinity. So positive x goes to positive y, negative x still goes to positive y. So this part here is describing the end behavior. It's telling the reader where the end point, it's not a point, but ends of the graph are pointing. The ends of the graph are pointing in a positive infinity behavior. It keeps going up forever and ever and ever in the positive direction. And that's all. That's all at once. So that's how you do that. Now I want you to just dissect this one. Don't graph it yet, but just dissect it. I can't remember on your notes if I fixed it or not, but I put a little squared right there on the second factor. So if it's not on your notes, then go ahead and add that. But pause it, dissect it, and come back, and then we'll graph it together. For this one, we end up getting the same x-intercepts because our factors, the inside of the factors are the same. That second factor has an x minus 3 squared. When you set that equal to 0, when you square root both sides, you just get 0 anyway. So you end up with x minus 3 equals 0 anyway. So that's why we have the same x-intercepts here. but the behavior at the x-intercepts is going to be a little bit different because of the multiplicity on x minus 3. So the exponent on x minus 3 is a squared, which means that at 3, we're going to have a U-shaped piece there. And at -2, we have a multiplicity of 1, so we're going to have a linear piece there. When we add our multiplicities together, we get 3, which makes a third-degree polynomial. And then when we find that leading coefficient, we get x times x squared. Remember that the x squared comes from here. If we were to expand that out, we would end up with x squared. So we get 1x to the third. So that leading coefficient is a 1. This means we have a positive odd degree polynomial. So let's look at a couple positive odd degree polynomials. If I have x raised to the, well, just x raised to the first. We have a linear function. The ends are pointing in opposite directions. So if I do x to the third graph, it's a cubic function. The ends are pointing in opposite directions. So odd degree means opposite directions. Now that +1 coefficient, it could be +2 or 3 or 4, as long as it's positive, means that on the right side of the graph, it's pointing up. The right side of the graph is positive. Now let me show you a negative. If I change it to a negative coefficient, that's going to change my graph. Now you can see on the right side of the graph, it's pointing down. So overall, if we were read like we read a book, left to right, if I were to start at the left side of the graph, overall, it's going down. So negative coefficient ends down, positive coefficient ends up. And that's going to tell us, that's going to be a roadmap for us as we graph. And then the y-intercept, you plug in 0 for x, you simplify, we get 2 times 9, which is 18. That's going to be a little bit off our graph, but we can get a pretty good idea. It's going to be fine. It's just a sketch. So now let's put all of our pieces together and graph the function, then describe the end behavior. So I still have x-intercepts at -2 and +3. My end behavior was a positive coefficient odd. So it's going to start low, end high. Opposite directions, positive means ends in the positive. And I say ends because I'm talking about if we start on this side, it's going basically up overall. That's not really like, anyway, that's how I like to think of it. I like to do little short memory devices like that to help me with this stuff. The y-intercept is at 18, so that's going to be way up here. We've got 11, 12, 13, 14, 15, 16, 17, 18, way up here. Oh, man. I hate that it does that. So I think that's all of our info. Oh, no, it's not. At -2, we had a multiplicity of 1, which mimics a linear function. And at +3, we had a multiplicity of 2, so that's going to mimic a U-shaped graph. And I know that it's a U-shaped graph like this, positive up here, because I need it to end up. If I needed it to end down here, I would need to flip it. So that's kind of how you decide whether it's facing up or facing down. Now we just join all the pieces together. So I'm starting down here, I cross through -2, I go all the way up to 18, then I have to make my way back down to this U part of the graph, go through 3, and then I end up here. And that's it. That's what it looks like. So once you have all your little pieces, then you just join them together. It forms that roadmap for you. Now to describe the end behavior, as x approaches positive infinity, y, is this f of x? Or did I do g of x? G of x, sorry about that. Got to name it correctly. y, g of x, also is approaching positive infinity. So as x gets bigger, y is also getting bigger. Then as x approaches negative infinity, y, in this case g of x, the y values are going in the negative y direction. So that's going to be negative infinity. So as x is getting bigger, y is getting bigger. And then as x is getting smaller, y is getting smaller. And that is how you would describe in behavior for a positive odd degree polynomial. And that's it. That's all you have to do. So let's go on to the next one. I want you to pause it, try it, come back. You can go ahead and try to graph it now that you know a little bit about in behavior and this negative coefficient. I want you to try the whole thing, pause it, try it, come back. On this one, I did expand it out. I multiplied it out so you could kind of see where some of the stuff is coming from. You can use FOIL or distributive method or whatever, but you would get, the reason why I did this is because that I was afraid that negative out front might kind of freak you out, but I just want to show you how it comes into play. So when you multiply it all out, you end up with negative x squared plus x plus 6. So this is not going to change your x-intercepts. That's why I brought it up, because I was afraid you might think, oh, I need to apply that negative to the 2 because of whatever. You don't need to, it doesn't affect the x-intercepts. And the reason why is because I have it written out here. If I have negative times x plus 2 times x minus 3 equals 0, if I just divide both sides by that negative, then now it goes away and we just have x plus 2 times x minus 3 equals 0. So you can kind of ignore it for the x-intercepts, but don't ignore it for the rest of the problem. So we still get those same x-intercepts of negative 2 and positive 3, but the only thing different here than in our first example is that we have that negative out front, and that's going to change our graph a little bit. Even though those roots, those anchor points are the same at negative 2 and 3, and the multiplicity is the same as our very first problem, the overall look of the graph is different because I have that negative out front. So this is still a second degree polynomial, so it's still an even degree polynomial, but now I have a negative coefficient, and that's going to force my graph to go upside down. Negative coefficient, even degree, it means that your endpoints are still going in the same direction, but now they're pointing down instead of up. And my y-intercept is now a positive 6 instead of a negative 6. So again, it changed a little bit there. So if you put the pieces together, we have negative coefficient, even degree means pointing down. So I have my arrows pointing down. I have two x-intercepts, one at negative 2, one at positive 3. The multiplicity was 1 at both of those, so they're going to be like a linear function there. And then I have a y-intercept of a positive 6. So then if I put all my pieces together, I'm just going to start on the left side. You don't have to, but that's where I'm going to start. I'm starting down here. I have to go through here. That was ugly. I have to go through here to get up here. And then I need to end down here, which means I'm going to have to go down and then end there. And that's it. That's all you have to do. So as x approaches positive infinity, what is happening to the y values? They're going in the negative infinity direction. So y approaches negative infinity. And then as x approaches negative infinity, the other side of the graph, y is also approaching negative infinity. So my y values are pointing down in the negative direction. And that's all you have to do. So last one, go ahead and pause it, try it, come back, graph it, do all the stuff, and then check your work. Again, on this one, there's a squared right here. So if it's not in your notes, add that. And then again, notice the negative out front. Okay, last one for the graphing, we still get those same x-intercepts of negative 2 and 3. At negative 2, we have a multiplicity of 1, which shows that linear function. At 3, we have a multiplicity of 2, which is going to mimic that quadratic function. This brings us to a third degree polynomial, leading coefficient of negative 1. So we have a negative odd degree polynomial. And then a y-intercept of -18. So be careful there with your negatives. Remember, the only time that it doesn't really come into play for this problem is the x-intercepts, but everywhere else it matters. And that gives us our pieces that we need to sketch our graph. This is a negative coefficient, odd degree. So I know that my endpoints are going to point in opposite directions, whether it goes like this or like this, like doing the disco. That depends on the coefficient. Since it's a negative coefficient, it's going to end pointing down. So on the right side of the screen, it's pointing down. And that's going to help me decide at my x-intercepts what the graph looks like. So I put my x-intercepts there, and then I put my y-intercept there. I kind of estimated where the y-intercept would be. So if I start on the left side of the graph, I have to go through -2, and it has to be a linear shape. So I'm going to start up here, and I'm going to go down through -2. My next stopping point is the y-intercept way down here. And then I need to make my way up to 3. And whoops, I didn't quite make it. Up to 3. And then I have to go through 3 like a quadratic. So it has to be a U shape at 3. And I need to end down. And that's it. That's all you have to do. It's just a roadmap. And then the last part where you describe the end behavior as x approaches positive infinity. Is this j of x? Yeah. J of x is going in the negative infinity direction. And then as x approaches negative infinity, j of x is going in the positive infinity direction. So the y values are going in opposite directions. That's kind of what that's showing. So that's all. That's how you would do that. That's how you sketch a graph, describe the end behavior, and that's it. So that's going to lead me to this very last example where we're going to write an equation given the following characteristics. So we're starting with the end and going to the beginning of the previous problems. So I've got a leading coefficient of 2, a degree of 5, and then I have x-intercepts. I wish I'd done multiplicity on these x-intercepts. Let's say, go ahead and add this. If it doesn't specify, if the problem doesn't specify the multiplicity, then you can just put whatever you want there as long as the degree is 5, since it didn't specify. But I'm going to go back and specify that I'm going to have a multiplicity of 2 here and a multiplicity of 2 here. Now, why does that work? I want you to pause and think, why did I do 2 and 2? What would make it have to be that way? Or one scenario where it has to be that way? For a degree of 5, that means that the exponents on my factors have to add up to 5. So you can do a different combination of that if you want to. You could do 3, 1, and 1, or 1, 3, 1, or 2, 2, 1. It doesn't matter. As long as it adds up to 5, then you're good to go. So these x-intercepts are giving me my factors. If the x-intercept is -1, then the factor would be x plus 1 in order for it to be that. And then if my x-intercept is 0, then if I add 0, I just get x there. And then if my x-intercept is 4, I'd have to subtract that over. So that's going to give me my factors. I'm working backwards to get those factors. So I know I'm going to have an x. I know I'm going to have an x plus 1, and I know I'm going to have an x minus 4. And then I did, for this problem, a multiplicity of 2 on -1 and a multiplicity of 2 on 4. And then the last piece is, it says there's a leading coefficient of 2. So I just need to throw a 2 in there. You can put it somewhere else. You could put it in here. No, you can't. That wouldn't work. You have to put it out front. And then I'm going to call this f of x. And that's all. That's all you have to do. So you just kind of work your way backwards there, manipulate the factors, the exponents on the factors to make sure that it adds up to a degree of 5. Don't forget your leading coefficient. And that's it. So this would be an odd degree positive coefficient. And we could find the y-intercept if we wanted to, but this is all it asked for. So that's all you would do. Anyway, that is all I have for this lesson. I hope you enjoyed it. If you have any questions, please let me know. I'd be happy to help, and I'll see you in the next one.